given the minimum value of this quartic and asked for the minimum value of this quadratic. Right, I've got to work out what P is. Now the quartic's a little bit awkward, but what we can see is that there's no x cubed term, there's no x term. It's actually a hidden quadratic. I can write it as x squared squared minus p squared x squared. Now you could do a little substitution, u equals x squared if you want, but I'm just going to go straight for it and complete the square in terms of x squared inside the bracket. So I'll get x squared, then it'll be minus a half p squared squared. That'll get me those two terms, and I'll need to minus a half p squared squared, which is a quarter p to the 4. And from that, we would get the turning point would be a half p squared minus a quarter p to the 4. And it's this bit that must equal minus 9, which means p to the 4 is going to equal 36, because I've just times through by minus 9. And then p is going to be plus or minus root 6. Now, we're not actually told which one to go with, so we'll come back to that. Let's focus on the minimum value then of x squared minus px plus 6. So again, I'm going to complete the square. This time it'll be x minus a half p squared minus a quarter p squared plus 6. Okay, it doesn't matter whether it's plus or minus root 6 because I'm squaring it. They'll be in different places depending on what it is, but we're only interested in the minimum. So the minimum is equal to 6 minus a quarter p squared, which is 6 minus a quarter times 6, which is 6 minus 6 over 4, or 3 over 2. And that ends up being 12 over 2 minus 3 over 2, so 9 over 2.